All right, you guys, you're on video. Let's see what we have. Fluorine. What's fluorine's number? 9. How many protons? How many electrons? Valence electrons. 7. Lose 7 and gain 1. Gain 1 and become -1. Lithium. What? 3 is its atomic number. How many protons? How many electrons? How many valence electrons? 1. Gain 1 or give up 7. Or gain, I'm sorry, give up 1 or gain 7. Give up 1 and become +1. What's that? An oxidation number, right? Can you have an oxidation number without an ionic bond? Say no. No. Okay. Is an atom anymore if you have an ionic bond? Say no, it's an ion. Okay, all right. Oxygen. What's oxygen's number? How many protons? Electrons. Valence electrons. Give up 6, gain 2. Gain 2 and become -2. Next one's phosphorus. What's phosphorus' atomic number? 15, I heard. 15 protons. How many electrons? How many valence electrons? 5. Give up 5 or gain 3. Gain 3 and become -3. Okay? So, the next thing I need to have you do is let's bring 2 of these together. How about I make a deal with you? I won't make you write the atomic model. Yay. So we'll start with the Lewis dot. Okay. But we're going to have to do one thing before we draw it. So I want you to just kind of go like that. You're going to do the Lewis dot here. But you need to first crisscross the oxidation numbers of these atoms. Let me show you what I mean by that. So potassium and fluorine. Folks, what's potassium's symbol? I heard it's K. What is its oxidation number? Whoa, oxidation. +1, I heard it. What is fluorine? What's its oxidation number? -1. Well, those two are going to get along just fine, right? This is called crisscross applesauce. So, what did I just do? I took the whole number, ignored the charge, and put that number on the subscript of the opposing element. Now, if you want me to explain the math, it's really simple. -1 times 1 is what? 1. +1 times +1 is what? 1. Add them together, you get 0. Right? Meaning they're neutral at that point. Okay? Now, that'll make more sense in a little bit. So if I were to rewrite this, I know I need 1 of each. Do you get that? So over here in my chemical formula, because remember we've got to have our chemical formula over here, you automatically know your chemical formula is going to be KF, potassium fluoride. Okay, so that's great. We got that part out of the way. See how we did that? And now I got to show a Lewis dot. So I'm going to come back over here, and I'm going to be like, okay, potassium has how many valence electrons? 1. It's in the first family, right? Fluorine has how many valence electrons? I heard 7. I think I heard 7. Yeah, I know it. I just. Do I circle them? Careful. Am I sharing them? No. If I see that, you're going to get it wrong. I want to see this. You need to show me that the electron is transferred, given away, not shared. You guys get that? If I give up an electron, I become what? Positive. If I gain an electron, I become what? Negative. Okay? I guess I should have put the crisscross here and the Lewis dot here. That's my mistake. Sorry about that. I forgot I wasn't going to make you do the atomic model. So let's do crisscross here and Lewis dot in the middle, okay? That's fine. So this is where the Lewis dot would have gone. You guys get that, though. And you call it whatever you cheat. I don't know, cheating method. Crisscross applesauce. How do you spell Chris? K? We'll just call it the cross. Okay. What? Sure, we'll do another one. Seems how I really goofed that one up, right? Okay. Let's do magnesium iodine. Okay, here we go. So, folks, stay with me here. You know you're going to have 3 different things. Okay. You're going to have the cross, the Louis dot, and then we're going to have the chemical formula. Okay, that's easy. Cross, magnesium. What is magnesium's oxidation number? You better tell me plus or minus, right? What is it? +2. What is iodine's? -1. Now it's going to get a little trickier than the last one. So, crisscross, right? So I know I'm going to need 2 iodines for 1 magnesium. So I need to write my formula as such. MgI2. If you want to check to make sure you're balanced, +2, if I have +2 and -1, I know I'm going to need 2 to equal these out. Yes? Okay, good. Question? Yep. We only take the whole number, okay? 1 times -1 is what? -1, okay? And what we're going to end up having to do is have these balance out. So 2 -1s, right? I'm sorry, -1 times 2 is what? -1 times 2 is what? -2. Plus 2 times 1 is 2. So these 2 have to balance out, right? Did you get that? Okay, don't worry about that. Just know the crisscrossing, you're fine. Let's put them together, okay? Magnesium has how many valence electrons? I heard it, 2. How many iodines am I going to need? 2. How many valence electrons does iodine have? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, right? Then you need to show me the transfer of electrons. You get that? Not hard, is it? No. Shouldn't be. Now here's the question. Here's the conceptual question. Looking at the periodic table, would I ever have 2 things with a negative oxidation number bonding ionically? No. Opposites attract. You will never see like 2 things that are, let's say in the families 1, 2, and 3, they will never bond with each other ionically. They'd have to be a covalent bond at that point. And you will never see families from 5, 6, and 7, well, and 8, because they don't bond, but 5, 6, and 7 bonding with each other, right? Because they have the same oxidation number, positive or negative, right? You get that? What about family 4? Let me give you and do one with family 4 real quick. Well, family 4 is tricky. Okay, let's go ahead and grab one. Give me family 4 and anything else on the periodic table. I don't care. Give me something out of family 4. I heard what now? I heard carbon. Okay. Doesn't matter. It honestly could be carbon. It could be, I gotta look on the period. It could be carbon. It could be silicon. I don't care. Doesn't matter. Okay. Well, let's look at carbon. Okay? Let me put it over here to the side, actually. There's carbon. It could be plus or minus 4. I don't know what yet. I'm going to leave it alone. What are you going to have me put it with? I don't care. Helium doesn't bond with anything. Calcium. What's calcium's oxidation number? +2. If they're going to bond ionically, this must be a what? That's how you figure it out. Ding, 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 ding. Okay? You get that? Depends on what you put it with. And if I put 2 together, I won't. Okay? I'll leave that for chemistry class next year. It's a whole other episode. All right? So what we're going to do here, just to solve this problem, because this is a good one to do. I'm actually very glad you gave me calcium. Brings up another issue that's going to come up. Well, I can, but I'm right here. How about that? How about this? Can I reduce 2 and 4? Right? You better do that, or it's going to get crazy on your paper. Okay? So if it's 2/4, we know that's 1/2, right? Same idea. So when I draw this, I go, okay, I need one of those, and I need 2 of these. When I draw it out, I know, okay, carbon has 1, 2, 3, 4. Calcium, we know, has how many valence electrons? Help me out. Valence electrons. It's in the second family, right? 1, 2. Calcium over here. 1, 2. And when you bring these, okay, well, this guy needs a buddy, this guy needs a buddy, right? This guy needs a buddy, and this guy needs a buddy. Right? Now imagine if you had like 2 and 4. Ooh, that'd get silly, wouldn't it? Okay. So you can reduce them. Well, what questions do you have about ionic bonding?